We want to look at logarithmic differentiation. Now we've solved, check my previous video where I treated product and quotient rule. Now in logarithmic differentiation, in product rule, let me go back. When you have two functions as products, that's when you use product rule. In quotient rule, you have two functions in form of fraction. That's when you use quotient rule. But why do we need to deploy a function called logarithmic differentiation? In logarithmic differentiation, you apply it when you have more than two functions as product or quotient. I will say that again. In logarithmic differentiation, you have more than two functions as product or quotient. So when you have such, you deploy logarithmic differentiation. For instance, if I have y equals u v w, I have three functions as product, or if I have y equals u v over w, I have three functions as quotient. That's when you deploy logarithmic differentiation. Now, how do we go about it? If I want to find the derivative of this, now all of these are in terms of x. So this is u of x, this is v of x, and then this is w of x. Now, if I want to do this, I want to find the y dx. Now, the first thing I'm going to do, I'll taking the lane of both sides, taking the lane of both sides of the equation. So that will be lane y equals lane u. Now for multiplication, I'm going to use plus lane v plus lane w. Now lane u, if you look at the standard derivative, lane x will give you 1 over x. So lane y will give me 1 over y. Then I will differentiate. I'm going to differentiate. I'm going to differentiate y. If I differentiate y, I'm going to get 1. So dot 1 dot the y dx. Since I'm differentiating with respect to y, you remember that you can check my previous video on implicit differentiation. So lane u will be 1 over u dot du dx, means I'm differentiating this, that I'm multiplying this by the du dx, plus lane v is 1 over v dot the derivative of this, that's what I'm doing, the v dx, then plus lane w is 1 over w dot dw dx. Now, so therefore, to get to y dx now, so the y dx will be, all I need to do, I might just multiply both sides of the equation. Multiplying both sides of the equation. I want to get rid of this y. So multiply both sides by y. Now, if I do that, okay, let me rewrite it again. 1 over y dot the y dx equal 1 over u dot du dx plus 1 over v dot dv dx plus 1 over w dot dw dx. So here, I'm multiplying both sides by y. I'm multiplying both sides of the equation by y. So y cancel y. So the y dx will be y into 1 over u dot du dx plus 1 over v dot the v dx plus 1 over w dot dw dx. So this is the derivative when you have more than two functions as a quotient. So let's solve a problem on that. Now I want to solve a problem on logarithmic differentiation. I said something about logarithmic differentiation, that in logarithmic differentiation is when you have more than two functions as product or quotient. So I want to take where we have three functions as product, for instance, y equals x raised to the power 5 dot exponential 3x plus 2 dot sine 2x plus 1. Now, if we have this, we have three functions in form of products. So what we're going to do, the first thing is to take the lane of both sides. So taking the lane of both sides of the equation. So if we do that, we're going to arrive at lane y equals lane x raised to the power 5 plus, for products you multiply, for quotients you subtract. So lane exponential 3x plus 2 plus lane sine 2x plus 1. So now the next thing I'm going to do, 1 over lane x will give you 1 over x. So lane y will be 1 over y dot the y dx. Now why? Because I'm going to differentiate the denominator. If I differentiate the denominator, I'm going to get 1 dot the y dx, because I'm differentiating with respect to y, equals 1 over x will be 1 over x5. Now dot the derivative of this. I'll multiply this by the derivative of this. The derivative of this will give me 5x raised to the power 4 plus. So this will be 1 over exponential 3x plus 2. Now dot, I'm going to find the derivative of this. The derivative of this exponential 3x plus 2 is a function of 3x plus 2. So I'll differentiate this first. I'll get 3 exponential 3x plus 2. Then plus, now this will be 1 over sine 2x plus 1. Now dot, now I'm going to find the derivative of that. Now I can see that sine 2x plus 1 is a function of 2x plus 1. So I'll first of all differentiate what I have inside. So if I differentiate this, I'm going to get 2. Then sine, the derivative of the sine function will give me cos 2x plus 1. Now I have 1 over y dot the y dx. I'm going to tidy up this. So this is 5x raised to the power 4 over x raised to the power 5 plus, so this is 3 exponential 3x plus 2 over exponential 3x plus 2, then plus, so this will be 2 cos 2x plus 1 over sine 2x plus 1. Now I'm going to do this. Let me tidy up this. So 1 over y. So I can multiply here. I can multiply through by 1 over y. So multiply through by y. Multiply through by y. Why am I doing that? I want to get rid of this. So if I do that, so this is y multiplied by 1 over y, the y dx. I'll do the same thing here. I'll multiply both sides of the equation by y. So this is the original equation. So I'm multiplying this side by y and that side by y. So here I have 5x4 over x5 plus 3 exponential 3x plus 2 over exponential 3x plus 2 plus 2 cos 2x plus 1 over sine 2x plus 1. Now close the bracket. Now this cancels this. So the y dx, you know my answer should be, the y dx should be in terms of x. So this y is this, so I'm going to plug in this for y. So I have x5 exponential 3x plus 1, plus 2, then dot sine 2x plus 1. Now this will cancel out this. I have this will cancel 4x raised to the power 4 cancel 4 of this. So I have 5 over x left, then plus exponential 3x plus 2 cancel exponential 3x plus 2. I have 3 plus. Now if you look at this, cos x over sine x will give me cot x. So for this, I'm going to get 2 cot 2x plus 1. So this is my final answer. So that's how to solve a problem on logarithmic differentiation when you have more than 2 functions as product. Thanks for watching my video. Always subscribe on OG's Wealth of Maths. Share my link. God bless you.